Okay, so
Do you have like a movie play now? I guess, or not? I can start? Right. So, hey everybody, my name is Victor. Good to be here, really excited. I'm here with my colleague Vlad.
hello,
What?
hello everybody.
Okay, and what we'll do today, we will present you a brief about things that we are building in our delivery center in Bucharest we are building. But first, I want to brief you a bit about Capgemini. At Capgemini, we are really people-oriented. This is a people company. Our culture and vision is towards building on people because our motto is people matter and results counts. Right? Because without having people and without having the right focus for them, you cannot have people and great results. So, did you heard about Capgemini? By the way, hands up. Okay, that's my team there. So we are a multinational company. Today, I think we are, as this slide shows, roughly 200K people worldwide. We are geographically distributed. For instance, the largest team we have, it sits around 100K in India. But also, we have a strong presence in Europe. Capgemini is a French-based company, but has been developed through the years to a global scale. What Capgemini is doing, actually, is providing consulting services in most of the known industry in the digital area, like digital customer experience, insights and data, cybersecurity, product engineering services, you name it. So whenever it comes to digital in this world, Capgemini has a lot of presence. And if you ask around in this world about Capgemini, will be, yes, are one of the great leaders in the consultancy for business services. Right. As a history, Capgemini started in 1967 with 7 people in France, and today we are counting, as I've said, 200,000 employees. As I've said, Capgemini, it's oriented to the digital area and as we all know, because we are part of this industry, we know that the digital area, the mobile, the cloud, IoT, and everything is gaining more and more ground, and this is what Capgemini is looking forward to be part of it. What we do in Romania? So in Romania, Capgemini started, I think, 11 years ago with the business consulting department, and up until now, we managed to reach the number with almost 1,000 employees with 3 offices. We have the biggest office in Iași. The second one is in Bucharest, where we have the delivery center I'm building. And we have a new office open in Suceava. The type of projects, and together with Vlad, we'll present one of the methodology for one of our projects that we are delivering from the delivery center. We are spread to industries like the one for today, which is aerospace and satellites, telco, banking, insurance, you name it. So to say, skills and services that we have, we'll have programming languages like C++, .NET, Angular, Java, everything you name it. In the testing area, we are really strong in automation. We have a part of some automation testing framework that we build for our clients, also from the local market, but also from the global. In the delivery center, we are working closely with our colleagues from other Capgemini entities, from France, from Italy, from Germany. And together we are building great products for our clients. As last topic on Capgemini, because I'm pretty sure, as I'm excited as well, you're excited to find out about the main topic of this this presentation. It's about TDD. I just want to say that we have a strong presence online with all the social networks, so feel free to contact us using these channels. And nevertheless, we do have a stand there with our colleagues there. You can also meet people that are working in the delivery center in Bucharest, and they can share with you the experiences we are building day by day. Now, so interesting subject, right? Building software for satellites. Did you heard about a satellite called Schiaparelli? Right, so Schiaparelli was one of the satellites that an Italy agency of European Space Agency had built together with Russia. And the intent of this satellite was to test the landing procedure of a satellite. Unfortunately, the satellite actually crashed, he was like almost 55 kilometers about to land on Mars. And for some reason, the system that was opening the parachute didn't open. Right? And this actually caused, I mean, if I remember correctly, the speed that the satellite was actually hitting the ground was sitting around maybe 500 kilometers per hour. The reason I'm saying that is because obviously after the researches, after this fail, was the fact that apparently it was a software issue, right? So therefore, I mean, if you can look at it, speaking about satellites and all other industries, you know, the quality of the software you need to put there on these devices needs to be really high, right? Because, you know, as everybody's saying, beep happens, right? And this is what we have in our minds when we are writing code for our client, which Vlad will going to tell you in a few seconds, is we really implemented and we have in our mind the test-driven development approach. And Vlad will tell you exactly how we are doing this. So I would say that will be my part, and I will let Vlad to take it over. I'll thank you, and pretty sure we'll talk later. Thank you, guys.
Thank you. OK, so as Victor said, we are going to talk about test-driven development. Today, we planned to answer for you to those questions: what, why, how, show you some results of TDD, and if you have any questions, you can ask us here if we have enough time, or you can find us at our panel, as Victor said. So let's move on. What TDD is? Whoops. OK. Most people think that TDD is unit testing development. Well, no, it's not. That's wrong, guys. So let me be clear and tell you the difference between unit testing and test-driven development. Let's say that we have this following example. We write some code. We have a function, calculate loan rate. As you can see, we have the loan amount, months, interest rate as input. And let's assume we have the functionality already developed. After we write this code and we compile it and we see that everything is OK with the code, we generally, as developers, start thinking to do tests, to write tests and verify our code. So there we go. We write tests. Let's say we check the values, the results, the parameters, whatever. But this, what we have here, is not TDD. This is unit testing. So what's TDD about? TDD is about and is based on the same elements as unit testing. We have also tests and also developed code. So in TDD, we usually reverse the process. We start with the tests, and then we write the code. Why? Because we have bigger advantage if we design the tests in the beginning than write the code. Here is a formal definition, if you want to say, about TDD. As you can see, it's a software development process that relies on repetition of very short development cycle. All requirements that we receive for our client are turned into use cases. Those are wrote in tests, and after that, we start to develop the code. Of course, we develop only enough code that all our tests has to pass, not more, no less. That makes efficient this methodology. Now, let's see the life cycle of TDD. As I said, first thing we do, we decide what our code should do. When we start the project, this is the first step. And after that, right after that, we write the tests. We have all tests implemented, or let's say, for example, we start with only one test, and the next step is to check that test fails. That's always what the test should do, always to fail in the beginning, because we have no code developed. That's logic. After that, when we saw the test failing, of course, you can say now, OK, but I may have some tests that won't even run or compile or whatever, because this is depending on the programming language. And that's true. You will have an error, it won't work, but that's the thing we need to do. We have the test. Then we go and write the code. And we write only the amount of code that we need to pass our test. And this thing, this process, this part here, is done for all new requirements, all new methods, all new code blocks in our project. When we have the test done and the code done, we check for all other tests. If, of course, we want to have tests passing from the first time. So we develop code until we have all the tests done. And after that, we refactor our code. And this is the life cycle of TDD. So let's move on and see why. Why do we talk about TDD? Why should we use it? I mean, just because I said earlier it's efficient and it's good, it shouldn't be that the reason for you to use it. So let's see what does provide. We have a plan and design before we code. And this is really, really important. Think about it. Let's say an aerospace engineer always, but always, writes a blueprint of a satellite before he starts to build the satellite and invest in that satellite. Because if you want to do like that, you may fail on Mars. And here, another example that I've heard, and I really like it. Think about a surgeon. A surgeon always lays out a surgical plan, but always, before any surgery. And I bet if you guys would be a patient and you'd meet your doctor before your surgery and see him unprepared and clumsy and doesn't know anything to do and tells you that he has no plan or can't provide you any details, I bet you'll be scared and you'll like to leave that hospital and won't be randomly cut by some unprepared surgeon. Next, we document the design. And this is very important because besides comments and the large documentation that we have, test always, but always, helps you to document your code because you can understand what that code should do. And it's easier for you to understand and to process all the information, even if you are new on that project. It's easier for you if you are looking to the test and you see what that code should do, how does it work, and that's OK. And if we are talking about code that's working, here we have the proof that code implements the design. Because it's working, you have the design that was made with help of our test, implemented, and this is the most important thing for any client you'd have. Anyone would ask for a prototype, for something that proves them they can invest in you and you deserve their money. So this is it. And the most important thing, from my opinion, on this slide is that TDD encourages design testable code. Testable code means you are forced from the beginning to develop simpler code. You won't have complicated code. We all know that complicated code is hard to understand, hard to manage, hard to maintain, and so on. So let's see the advantages. First of all, it cuts development cost. You will spend less time in developing, so you invest less resources, and that's OK for you and also for your investor. Increase the developer productivity. How? Simple. We, as developers, we all know that we need time for debugging. And usually, debugging takes, let's say, 70% or more time than the coding phase. And because we have the test at the beginning, you will spend a lot less time in debugging phase. Of course, you will be in situations when you need to do debug, but usually, in most of the cases, you will find the problem quicker. Shorten the development feedback time. This is true because, think about it, if you write a code and you have already the test for it, and you run the test, you see always and really fast what you're doing and how you can fix your problems. And this is, again, for your costs, for cutting development costs. Next, we have effective, organized, and neat clean that works. So this is our proof that our codes and our projects work as intended. And besides all these things, it's clear that we improve the quality of our code and we reduce bugs. As I said, simpler code equals less bugs. We all know that complicated code makes you struggle when you're developing and reduce
yeah, think about it. You will deliver an already tested code, right, to the testing team. Like
yeah.
And we will show you some great numbers that we achieved after we implemented this methodology. But it is that simple. I mean, imagine that part of the development in the beginning will be start thinking about your test. And what Vlad said is like, okay, so what can go wrong, right? This is what I need to do. This is what I need to implement. Okay, so my mind, like risk-oriented, so to say, is like, what can go wrong? Because as Vlad said, you will start, you cannot build a test to actually validate something because you don't have a code that works at the beginning. You just start thinking, about what can go wrong.
Yeah, exactly. So, okay, now we know what and why to use TDD. Let's see how. But before that, I want to tell you what for are we using TDD. As Victor said, we are using it to develop software for satellites. Our client is a European Space Agency, and in partnership and tight collaboration with a key player in aerospace industry, we are developing. No.
So you see, it's happening.
Oh, come on. Wait a second. What? No. Okay. Sorry, we have a tricky cable today. Okay, as I was saying, we develop software for satellites. But you will ask me, maybe, what kind of satellite or what kind of software? Because there are a lot. Well, about the satellite type, I can tell you that we develop telecom and geolocation satellites. And about the software, we are developing actually the software for the satellite. You can imagine that a satellite has a modular architecture. And each of those modules has, let's see it like an equipment, a black box. We don't care what is inside that. And even if you care, I can tell you, because it's confidential. So, Not again. Okay. Sorry. Come on, come on, come on. Okay. So we are developing the code for satellite, for modules that implements, let's say, the propulsion, the movement of solar panels, the moving of the satellite from one orbit to another. And let's go back to how. We are using agile methodology. Why? Because TDD is using and it's working perfectly with methodology agile. And in our case, we use Kanban, but I won't bore you with this methodology because I hope everyone knows it and you can find it anywhere. So let me tell you about our team. We have a big team, as you can imagine, and we have a geo-divided team. We have a part of the team in France for project management and client interface and validation and integration, and another part in Romania for development and validation. A usual day at work for us is starting with a daily meeting where we use an interactive touchscreen board, and with that we establish our goals, our daily achievements, and we discuss any kind of problem or a blocking point if we have any. After this meeting, of course, everyone is going back to their job, to develop tests, to analyze specification, to develop code, and so on. Of course, for us, it's very important that we have the continuous integration platform. Why? Because having a big team on this integration platform and behind it, we can deliver faster and better, and that's what we need. Come on. Okay. Of course, our daily commits and our scheduled automatic tests are helping us and making our working process more rigorous, and we deliver better. Moving on, for each development, we have the client input and our deliverables. About client input, as you can see, we have all documents, all specification, all requirements. Proprietary framework that we need to use for our work to be done. Specification of development and specific libraries if needed. And for sure, we have to deliver reusable software if it's necessary and applicable. We always have to develop the code and deliver the code, always the tests, and deliver some documentation. A lot of documentation, but that's the good part, because we have always software validation testing plan, software validation testing reports, and quality metrics, KPI measurements, and so on. As you can see, we have a software validation plan, always a global one, that's created for validation strategy, which is common for all the modules that we develop. Of course, we, Capgemini, refine with our client the input and the output of any new model, because there can be situations where, I don't know, let's say an aerospace engineer can't tell you what data type to use or how a methodology should work exactly. He knows the math and the physics behind that, but you have to implement that. And for me, because I like math, it's awesome when I find integral fractions and so on. Okay, now let's see exactly how, because I told you so many things, but exactly how do we do? For me, for example, when I receive a new model, actually I receive a software requirements specification document. And with my team and our client, we discuss that software requirement specific document, and we establish our requirements. Then we write them, we group those requirements in use cases, and the use cases in tests. And as you can see, we have a list of requirements, a list of test case, then the test code itself. After we have this and we have the validation testing plan approved by our client, we start to code, but never, never, ever before the test. Now, we know what, how, and why. But let's bring you some, let's say, interesting results, our results. In 15 months, we got only 89 issues. And by this thing, issues, I mean small observation that we have to adjust with our client. Not errors, not development errors. Only issues about data type, methods, and other requirements that weren't clear. And the biggest performance that we had, only one development bug. Only one in 15 months. I know. You will say that I'm joking or I'm lying or it's impossible. I know, it sounds awesome, it's awesome, but this is it. This is our performance, and this is the result of TDD. If you are doing it good, it's great. You have good results, and your client will always, but always be amazed by your work.
And the client will fire or his QA team,
Yeah.
which actually happened.
Okay, so now you see what, why, how, and the results. If you want to get only one bug in 15 months, and we try our performance to be on more time to let that only bug to not get any more, you can try using TDD. This is a recap. What we talked about. This is the, let's say, basic workflow for TDD. We have the requirements, we make the use cases, written test, developed code, and refactoring everything. Why? Because it encourages design of testable code and reduces bugs. How? We are working for satellites, European Space Agency, as I said, using Agile, having documentation, and a rigorous working process. Behind the satellite, as you can guess, it's rocket science. Satellite science, but the same thing. And our TDD result, only one bug in 15 months. That's all for me. Thank you for your attention, and any questions if you have.
No questions? Yeah.
Please.
Have you ever had to rewrite a method due to later tests? I mean, it passes 5, 6 tests, and then the 7th breaks it, and you realize you have to rewrite the method.
Can you repeat, please, or speak louder, because I really didn't hear you?
Have you ever had to rewrite a method due to a test? Meaning the method passes the first 6 tests and the 7th breaks it, and you realize you can't.
No. Usually, each test, how we develop, is for a big part of the module. And we won't have to rewrite the procedure. We only have different tests that test different parts of our module. But you won't modify the procedure. You won't rewrite code before editing any test, or you won't edit your test. Of course, there can be cases when, I don't know, if you have an evolution, for example, on your module, then, yeah, if it's new functionality, you have to rewrite a test or develop another one. But that's another thing.
No, I meant, no, I realized the test should be written. I meant if you have to write the implementation to pass more tests.
But no, if your code works, you don't have to rewrite your test. The test is done in the beginning.
Only one bug. One bug.
So
You read it down, it stays there. Because that's the main advantage of TDD. Once you have all the tests and the Swiss there, it stays there. You don't need to rewrite it or adapt it, only if you have new development.